Okay, we're going to start the new chapter, the forecasting. So basically, you do forecasting, let's say to predict whether today will be rain or not. And then here we are going to do the time series forecasting. So first of all, what is time series? Time series is a collection of equally spaced temporal data. For example, you collect the daily uh, COVID cases, maybe daily the gold price, petrol price, and so on. So that is what we call time series data. Okay, here for example, this is monthly airline passengers data. Okay, time series can consist some or all of the components such as trends, okay, cyclical, seasonal, and irregular variations. What's trend? Trend is a long-term pattern. Cyclical is actually repeated up and down movements. Seasonal is a regular fluctuation during the same month or quarter. For example, you may have, let's say, during semester break, there's a low electricity consumption because there's no student in the campus. Or maybe, let's say, winter or summer you have a more electricity consumption because winter you need to turn on heater, summer you need to turn off air conditioner to cool down. Okay, then here you show the trends. This is a trends. Okay, uptrend mean increasing, downtrend the decreasing, up to down, this is down to up, this is horizontal or we call statics. Okay, time series. So forecasting is actually we predicting future value based on past and current time series data. Okay, we got type of load forecasting. Okay, can be divided into short-term load, medium-term load, and long-term load forecasting. Short-term load up to 1 day or 1 week. Medium-term load from 1 day to several months. Long-term load forecasting more than a year ahead, and there are suitable applications there. Okay, we got the time series data of monthly UTHM electricity consumption in main campus from year 2009 to 2020. Then we are going to use the Excel trend line equation to do the simple forecasting. And then the Excel built-in forecast function, which is equal forecast. This is the X value that I'm going to forecast based on historical Y value and historical X value. And then we evaluate the performance of different model using the MAE, which is mean absolute error. The absolute YT is a real data, cap YT is a forecasted data. So the absolute value between real and forecasted is what we call absolute error. When you sum up all the absolute error, divide by number of data, so you get mean absolute error. When you have the absolute error divide by the real data, you got actually is a relative error. And then you sum it up, you divide by number of data, time 100%, you get mean absolute percentage error. When the absolute error, you square it, so you got actually the squared error, you sum it, you divide by number of data, you get mean squared error. And then when you take the square root of the MSE, you get the root mean squared error. These are the result. I mean the plot, yearly plot. I mean this is for example, this 2009 electricity consumption up to 2020. This is a collection of monthly data in time series plot. We got our blue, it's a real data. Then show this is a linear trend, using Excel. This is a cubic, this is a, I'm not sure which one, forgot already which one, the poly actual. The red color should be the quadratic, the green is a cubic. Then you have this is a power model. Okay, exponential model, logarithmic model. Okay, this is using the Excel forecast function. Okay, these are seven model with their MAE, MSE, MAPE, and it's noticed that cubic model is a contain give the smallest errors. Okay, now we are going to show how we do it. First of all, we are going to plot the figure 2, the time series plot. Okay, selects the data, then inserts scatter plot. So you see the lighter blue is the correct actual data. Okay, but the month is wrong. We want this one to show year and month, like this. You want year and months. So okay, your chart is selected. So you select the data, remove the months, remove the actuals, and then you add series name, click the label for actual. Okay, series X value, select from 2009 1 until here. Series Y value, here. So you see your label for X horizontal axis label 2009 1, okay, and so on. And click OK. Okay. Yeah. So the horizontal axis label still not correct. So you select chart type line. Okay, right click sir. Format grid lines, select no line. Okay, you can change the thickness. Okay, change the color. Okay, thickness. Okay. After that, this one. So we have this one. This is our actual data. So you click the graph, the charts there. Right click, add trend line. So you got so many trend line that you can add. Let's say we choose, first of all, you choose a linear. Display equation, display R squared. So you get our linear model. Then use this linear model to forecast. Of course, okay, let me change. Right click, format the trend line. I want to change the color, let's say to red color. The width of the line 2 point. Okay, of course you see linear model not predict it very well because you see our data got the cyclic movement, but this is only the linear graph. So the equation is 2, so it equal 2.7629 times x. X equal to 2.7629 times x. Shift here, 2 here. Okay. What happened? 2. This is 3. Okay. Equal 2.76 2.7629 times t plus 2038.1. Okay, let me Let's see whether we get the same model. Yeah, same thing, 2038.1, same. Okay, then you just drag it down. So if you want to forecast, let's say 2021, you can do it. Okay, if you want, let's say 2022, you can do it because it's only based on the T. Oh, there's something not correct. Okay, T. Okay. Okay, do you see? The X should be my T. T should be collection of the months. So you can forecast to whatever because we got the T there. You have the T there. Cause using linear model, the Y is depending on the X. X is actually the time T, collection of the months. Okay. And then of course you have this is a real data, this is a forecasted, then you have the errors there. Right. This absolute error with the ABS of the real with the forecasted result. You get absolute errors. Okay, then you can have the absolute error squared it. This is what we call squared error. And then you can have the relative error. It's actually your absolute error. You divide by the Y. Okay, the Y is the actual data. So squared error is actually your absolute error. You squared it. Relative error is actually your absolute error divided by the real data. Okay, then you can copy it down for all the 144 data. Here 144 data. So the errors we just calculate between real and forecast. So for year 2021, 22, I don't have the real data, so I cannot calculate the errors. If you go to calculate the errors, will be quite big because this is nothing. So means 0 minus this one, the errors will be quite big. Okay, to get the for the absolute error column, we can get MAE. Squared error column, we can get MSE. The relative error column can get MAPE. Okay, MAE is the average of your absolute error. So ABERA, average. Okay, when you average down, okay, when you take the average of your absolute error, you get mean absolute error. All right. Because you see the error analysis. Okay, average is actually you sum out all the here divide by n. So this is using one built-in command which is built-in function which is average. Average. Then we can copy the formula. So you see average of all the squared error you get MSE. Okay, if you this is actually MAPE, you have to multiply 100% because you average all the relative error and then time 100%. This is a mean absolute percentage error. It's about 31%. 31%. The error is quite big because you can see from the trends it's not well predict straight line, but we got the cyclic pattern. So this is for the, okay, this one is for the linear trend. Okay. And then the same thing you can, let's say, do for quadratic, right? So just click, okay, here, right click, add the trend line, let's say quadratic, so polynomial of degree 2. So display equation on chart display R squared. So you get your quadratic. Okay, right click, format the trend line. I want to change to other colors. The width, let's say to 2 point. And close it. So you see this is a quadratic equation. So you can use this quadratic equation to get the, okay, the quadratic model forecast result. So equal to, say, negative 0.3359 time. Okay, x is a t squared plus 51.472 times t plus 852.89. Okay, and then you can actually copy all these things. You see, they follow the pattern J with K. Okay, then okay, or one. I want it when I copied. Okay, the real date column F2 remain column F2. I put it here. Okay, so now I copy Control C, Control V. So you see my absolute error. Okay, the real data remain in column F2, column F. So deduct my, okay, here, quadratic model, which is K2. So correct. Squared error is the absolute error, squared it. Relative error. So it run, my Y run. So relative error, the F2 also you have to put dollar. So that when you copy it, it maintain to the column of F. See, I copied now. Now remain. Okay. So now I can select, okay, the quadratic error, including the, okay, absolute error, squared error, relative errors. Okay, and then I can sorry, Control C, copy from here. This is a quadratic model. Okay, we forecast it. Okay. So, okay, the quadratic model, we get the 14.92. 14.92. Oh, why different? 31. Quadratic. Okay, let's check the quadratic equation. Negative 0.3359 plus 51.472 plus 852.89. Sorry. Same. Why the errors? That is a mistake, I think, here. This one, this value, because I just check, okay. Mean the mistake in the slide is actually quadratic. Last time I key in as, I think, 59, I key in as this one. I key in wrongly when I built the slide. So you get the MAPE 15.01. So it should be negative 0.3359. So the MAPE is 14.9267. Okay, 9267, 14.9267. Okay. And then similarly, you can do, okay, you can complete for other model, cubic, exponential, log, power, the Excel forecast. Okay, Excel forecast. Oh, you do the Excel forecast. Okay. This one. This is our value. Okay, I use, okay, the previous 12 months to predict the month 13 using the Excel forecast. Okay. The X, I'm going to predict month 13, so I click the T13. Okay, using the known YS, the known 12-month Y data with the known XS. Okay, and then you copy it down. Okay, using Excel forecast, you can forecast 1 month ahead only, because month 145 depend on the previous 12 months. Okay, and then you're lazy to do all the error analysis, you can just copy it. Let's say Control C, put it here. Because we start calculate from here, I put it here. No, because this one we don't have a real data, we cannot calculate the errors. Then lazy to calculate, you can copy the formula, Control C, put it here. So click back, H2. Okay, just chain it up to here. Then you can copy. From here, you copy times 100%. So the Excel forecast is 13.84. Is it correct? Yeah, correct. So the rest of the model, please try it by yourself. And then you may ask how to plot this graph. How to plot this graph, this one, by the yearly plot, how to plot it. Okay, I got. Okay, we'll do it like this. New sheet. Wait, am I? Okay. Okay, this is the 2009 data, and you cut the 2010 data. This 2010. So you cut the data into column. One shot. I cut it one shot faster. 12 month. Okay, put the data. Okay, let's say we have a try insert scatter. So series 3 and 4, 12 data. Series 3 is actually here, 496 until 1004, about 1009. Okay, so it's correct. Huh? So, but we want to show series 3 as 2009, series 10 at 2010. 2010. So again, select the data, remove it, and then you add the series name 2009, series X value here, series Y value, this one. Oh sorry, this is G. So you see 2009 is in, and then you add series name 2010. Okay, series X value, this one. Okay, Y value, select the 2010. Okay, Y value. Okay, no, what's wrong? G2 to G13. Okay, so you got 2 years. Okay, add in series name 2011, X value, this. Okay, Y value, other way. Okay, and if okay first because it high. So we have 3 years already. Can change to I think line. Wait, where's the 2000? blue color, where is it? Never mind. Okay, I add series name now. Already 11, 12. Series value 12. Okay, and then add series name 13, series value 13. Okay, and then add series name 2000, okay, 14, series value, okay, the Y value for 2014. Okay, add uh, 2015, series value, the Y value for 2015. Okay, and then add 2016 value, 2016 value. Okay, and then add 2017 X value 2017. Okay, then add uh 2018, 2018. Then okay, add 2019, 10. Okay, then add 2020, the value is here. Okay, okay, let's see whether correct. Where's my blue color? Should have a 12 plot. Missing, I think, the gray color. Where is it? I remove it. I add 2009, the value. This one go back to the back. Here, just I'm missing this one. Because just now, okay, don't know what happened, and then I add it later on, so it at the back. It become at the back. Mm. So that's how we plot this yearly plot. Mean remove again. First of all, you select, let's say, 2, 2, and then you insert scatter. So we want series 3 display 2009, series 4 display 2010. So that's why, okay, you select data, remove, remove, and then you add series name will be 2009. X value is the value of the T. Okay, the Y value 2009. Okay, so you got 2009. Add series name 2010. X value is here. Okay, Y value. Select the Y value. Okay. Then okay. Put it back here. And then select data again. Add series name 2011. X value here. Y value. say I change to line. Okay, and then I select data, add. After the line, just series name, and no need to select the X value anymore. Okay, I already have three, right? 2011. So the series name 2012. The value for 2012. Okay, and then add 2013, value for 2013. uh, J to K, J to J. Okay, add 2014, then the value for 2014. Okay, add 2015, and the value for 2015. Because L, when you drag, add 2016. So I select only 2016. Okay, add 2017, the value for 2017. Okay, later on add 2017 already, right? Okay, now 2018. I select the 2018 value. Okay, then add 2019. Okay, then lastly add 2020. Okay, 2020 value. Okay, done. So that's what you get. Okay, January to December from year 2009 to 2020. The gray, this is a 2009. Okay, I think 2000, of course, this one 2020. Okay, so the sheet one, okay, leave it to you to maybe I perform one more for you to see the cubics. Cubic. Select this one, add trend line, polynomial degree 3, display equation, display r squared. Now you get this cubic. Check with correct 513. Okay, so you can do here cubic equal to 0.0022 times x is the t, t is here, cube, t cube minus 0.811 times t squared plus 79.124 times t plus 513. Okay, then you can copy the errors. Okay, select, okay, the whole cubic. This one, and make it a bit round here. Okay, copy it down until one data 144. Okay, this is a cubic approximation. Okay, forecast. Cause you can forecast to whatever month. Cause it only depend on time t. And then the errors, okay, you can only calculate until data 144 because you have to compare the real and the approximate data. P2 average, correct. This one is see whether you calculate. Okay, and the O, okay, correct. So it's 12.64, 12.64. Yeah, correct. So we have shown okay, the linear, quadratic, cubic, the Excel forecast, the exponential, long, and power, up to you to okay, do as your exercise. Okay, so with this, thank you for your attention.